Alright, in this video here we're going to be talking about joint variation. So if you haven't seen my other videos that I did on direct variation and inverse variation, I would encourage you to check those out before you watch this one, because this one just kind of builds on the stuff that I talked about in those videos there. Alright, so joint variation is something that happens, it's almost like direct variation, but with more than just two variables, right? Direct variation is just y equals k times x, where you have the variables y and x, and you have that constant k. So direct variation and also inverse variation are just how two variables relate to each other, right? Joint variation is when we have three or even more variables all related to each other. So joint variation is basically like direct variation in that it's all just multiplication, but it's with three variables instead of just two, right? So the basic formula for joint variation is z equals k times x times y, where k is not equal to 0, right? K, once again, is what we call the constant of proportionality. The variables here are the z, x, and y, right? So if you looked at those videos that I did on the direct and the joint, or the direct and the inverse variation, we looked at a couple examples that are from basically from the world of physics. A lot of the sciences and the laws of the sciences are written in terms of variation, but a lot of times we have more than just two things that are working together at the same time, right? We might have three variables that all conspire to figure out what's going on. So in a case like that, we use something like this with the joint variation that relates to three variables. So some of the key words that you'll see in a word problem that let you know that it's joint variation as opposed to one of the other types, it might say that z is proportional to the product of x and y. Well, the product of x and y means x multiplied by y, so if it's proportional to that, it's just k times x times y, right? Or you might say z varies jointly as x and y. All right, so when you see varies jointly, that's this one where they're all multiplied together. Or you might say z is jointly proportional to x and y, right? So some words to those effects let you know that it's joint variation as opposed to direct or inverse variation. All right, so those are the key words to look for to know that this is what your basic formula is going to be. I'm going to pause the recording real quick and erase this stuff and put up an example problem where we deal with some joint variation. Alright, I put up an example here, kind of a long one. So the force of wind blowing on a vertical surface varies jointly as the area of the surface and the square of the velocity. If a wind blowing at 50 miles per hour exerts a force of 75 pounds on a surface of 500 square feet, how much force will a wind of 75 miles per hour place on a surface of 10 square feet? Alright, so this is the type of problem that when I was a student learning math and learning physics, I would see this and be like, I think I'm just going to skip this one and not even try to do it. But it's really not that bad if you just kind of take your time and work your way through it, right? And again, if you haven't watched the videos that I did yet on the direct variation and the inverse variation, you might want to stop this here and watch those and then come back to this one, because we're going to use the same methods that we used to solve those problems. This one just has more stuff going on because we have more variables involved. All right, so first thing, identifying what type of variation we have. Blah, 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 varies jointly. All right, so right here, I see that I have joint variation because it says that the force of the wind, whatever, varies jointly as all that other stuff. All right, so varies jointly lets me know that I'm going to have an equation that looks something like this. All right, so now what I need to do is put together the equation that I can use to solve this problem. All right, so the force of the wind varies jointly. So let me start with the force of the wind, F, equals, right, and I use F for force here, equals the constant K times two other things. So it varies jointly as the area of the surface. So let me use A for the area of the surface and the square of the velocity. All right, so I have the area of the surface, the force of the wind, and then the square of the velocity. So I'm going to use V for velocity, but since it's the square of the velocity, that's going to be V squared. Right, remember, when it says the square of something, it means raising it to the second power. It doesn't mean the square root of that thing. If it was supposed to be the square root, it would say square root, not just square. That's something I've seen students make a mistake on in the past. They see square and they think, oh, that's that square root thing. No, square means the second power, so make sure that becomes a V squared. All right, so this is my setup for this problem. This is the general formula of, the force of a wind on a vertical surface varying jointly. Varying jointly means all these things on the other side are going to be multiplied together. I have the constant of proportionality K, it varies jointly as the area of the surface, A, and the square of the velocity, V squared, right? So there's a lot of information in this problem here. You have to make sure you read it carefully. One, picking out what type of variation you have, and then two, picking out what variables you actually have. We have the force, which I denote with an F. I have the area, which is the A. The square of the velocity, which is the V squared, right? If you miss that square there and you just put a V, you're not going to get this problem correct, right? So you got to be real careful. You got to pay real close attention to all the wording of the problem to make sure you set up that equation correctly. Because if you don't have this part set up correctly, you have very little chance of actually getting the correct answer, right? And just like I said in those other videos that I did for the direct and the inverse variation, labeling these with not just X, Y, and Z, but with letters that actually, reference what each thing stands for, like F stands for the force, and A stands for area, and V stands for velocity, is going to make it really helpful, especially for one of these with joint variation where we actually have three variables here. When I have to start plugging numbers in, which is actually the next thing I need to do, when I start plugging those numbers in, it's going to help immensely to not have to second guess where each number goes. I know that the area goes for A, the velocity goes for V, and the force goes for F, and I just put those numbers in the right spot. Right? So again, I would strongly recommend that you don't just use X, Y, and Z, but you actually use letters that relate to what your problem is talking about. All right, so F equals K times A times V squared. And now what we need to do, just like in those problems that we did in the direct and the inverse variation, we need to figure out what that constant K is. In order to do that, I need to plug in the numbers for F, A, and V, right? So in order to proceed with this problem, they have to give us, some set of numbers that all go together. And that's, the first sentence here is basically helping us set up our basic formula. The next sentence is going to give us the information we need to solve for that constant. And then the last part of it is what we need to actually answer the question and solve the problem. Right? So the next thing they say is if a wind blowing at 50 miles per hour, right? So that's going to be my velocity is going to be 50 miles per hour, exerts a force of 75 pounds, right? So my force over here is going to be 75 pounds on a surface of 500 square feet, right? So my area A is going to be that 500, right? So again, in order for us to proceed with this problem, they have to give us all that information, a force that goes with an area and a velocity, and then we can plug all those in at the same time and solve for the constant K. All right, so let's do that. My force F is a force of 75 pounds. And again, since I labeled this F instead of just a Z, it's really easy for me to figure out that that force of 75 pounds goes in place of the F, right? Equals K times A, right? Well, A is my area, and the area of the surface is 500 square feet, so there's my area is 500. And then my velocity is 50 miles per hour, so that's going to be 50 squared. Right? Again, if I just had Z equals KXY here or KXY squared here, I might have a hard time at this point figuring out where to put each one of those numbers. All right? And now what I need to do is solve this for K. I got to figure out what K is equal to. Right? So at this point, remember to do the arithmetic correctly, right? It's not hard, just don't screw it up, right? So remember, 500 times 50 squared, you have to do the exponent 50 squared before you multiply it by 500, right? Don't do 500 times 50 and then square that, right? Order of operations, PEMDAS, parentheses, then exponents. I have to do the exponent before I do the multiplying. Make sure you do it correctly, otherwise you're going to mess it all up, all right? So 50 squared, so I do 50 squared, and then multiply that. That equals 2,500. Multiply that times 500, and I get a huge number. Right? So 75 equals K times 125, and then 4 zeros. So that is 1,250,000. Right? So 75 equals K times 1,250,000. And then I divide both sides by 1,250,000, and I'm going to end up with a really small number here. Right? So when I do 75 divided by more than a million, that's not going to come out very big. So 75 divided by that number there gives me, my calculator says, and let me see on the screen here. Let me put this up here so you guys can all see it. So K equals 6e negative 5. All right, so depending on what type of calculator you have and what the settings are as far as how it shows you the answers, it may give you a decimal number for this, or it might give you something like this where it just says 6e negative 5. Right, so if your calculator gives you something that looks like this, that capital E there means scientific notation. Right, this means 6 times 10 to the negative 5th power. Right, if you remember scientific notation, what that means is it's that number 6 with that decimal point here, and then we move that decimal point 5 places to the right. So 1, 2, 3, 4, 5. Right, which means we have to add 4 zeros in front of that 6, and then that's our k value. Right, so my k is equal to 0.00006. All right, that's the k value in this particular situation. All right, so again, when you see, well, going back here, right, we set up our formula. We kind of already went through that a couple times. We plug in all the numbers. We do all the calculations following the order of operations correctly. We do everything we need to do to solve for k. If you get something like this, that e negative 5 or e, if it was like an e to a positive number, so it was like e4, that would mean move the decimal point 4 places in the other direction, right? Negative, e negative means move it to the left. E positive number means move it over to the right. In this case, since it's e negative, I move it 5 places. I get my k value of 0.00006. All right, now that's not the end of the problem. It seems like that should probably be the end because that was kind of a lot of work. But that's not what this question is asking us for. It's not asking us to find the constant of proportionality. It's asking us how much force will a wind of 75 miles per hour place on a surface 10 square feet. All right, so I'm gonna have to erase some of this stuff in order to do this last part. All I really need out of all that is my basic formula that I started with and the k value that I came out to. All right, so my k value is 0.006. So my formula now is F equals 0.00006 AV squared. Right? All that work is just figuring out what that constant is so that I can then use that to actually answer the question, how much force will a wind of 75 miles per hour place on a surface of 10 square feet? Right? So I'm looking for the force. So I'm trying to figure out what F is. I have the 75 miles per hour, that's my V, right? That's velocity. And the 10 square feet, that's my area. Right, so now I can just plug those numbers in for the A and the V. I'm going to get rid of this over here. Right, so we get my force is equal to 0.00006 times the area, which is the 10 square feet, times the velocity squared, so that's going to be times 75 squared. Right, and once again, last time I'm going to say it on this example, but labeling these the F, A, and V instead of just X, Y, and Z makes it a whole lot easier when you get to this point of plugging those numbers in, of knowing where to put each number. All right, so now I'm just going to go to my calculator. I'm going to type in 0.00006 times 10 times 75 squared, and that comes out to 3.375. Right, so my force is 3.375. And my force up here was measured in pounds, so this is also going to be measured in pounds. Right? Whatever the units were on the numbers that they gave us, we use the same units when we get our answers. All right, so we've got there a force of 3.375 pounds is the force on this vertical surface of 10 square feet when the wind is blowing 75 miles per hour. All right, so once again, when you're doing variation problems, first thing you have to do is identify what type of variation you have and recognize what that equation is going to look like. In this case, joint variation has z equals k times x times y. Set that up with the appropriate variables. Look out for things being squared or cubed or square roots or things like that so you can make sure you put those into the formula correctly. Then you plug in all the numbers they give you in order to solve for the k value, which is what we had up here before, which I had to erase. Once you get that k value, you put it back into the general formula here, and then you plug in the other numbers they give you and actually solve the problem that they're asking you to solve. Right? It's the basic way you approach all of these variation problems. The only thing that really changes is what type of variation you have, and that then affects what your equations look like. All right, I'm going to do another video also. So I did the one on direct variation, inverse. This is joint variation. I'm going to do another one where we just kind of mix them all together. So that'll be a lot of fun. Make sure you check that one out.